Hi, in this video I will be covering a lesson on how to use right triangle trig when we have angles of elevation and depression. So basically it just means we're continuing to solve right triangles using right triangle trig, but in the context of some application problems. So for the announcement today, it says you'll learn to apply right triangle trig with word problems. You will not understand this if you are still struggling with labeling sides, setting up trig ratios, and solving. So if you're still having difficulty, you have a test in 2 days. Please make sure to make an appointment with your teacher so that we can help you with these concepts individually, but schedule those ASAP, okay? Your test will be this Friday. So today you're going to go to Delta Math, and everything will be on the lesson titled 1118 Angles of Elevation and Depression. You're to watch the video, take notes, and writing down the work that I do for the problems. This is not a long assignment. However, I'm doing most of the problems in the notes so that you can catch on to how to draw a picture and where to label things. So please make sure you are putting everything that I write down on my notebook paper in your notes, including the notes which will be at the beginning of the assignment. So then you are to complete the remaining problems. There are only 8 problems in the assignment. My plan is to do 4 of them and then set up the pictures for 3, but then you will solve the others independently, okay? So I'll help you with the pictures and labeling, but you'll need to go solve them on your own. And then when you're through, you will click here to submit your notes and work. Let me make this clear because some of you all, when we have checked homework or like your notes, you all are writing work but no triangles. That is not going to be helpful when you study. You are not going to be able to look back in your notebook on test day and go, oh, how did we do that problem? Because none of the problems will remind you of what we've done because all you have is numbers written down. Draw the triangle, have it labeled with A, H, and O accordingly, and show your work and your answers, okay? We can't give feedback if we don't understand what you are using or what answers you got, therefore, whether it was set up correctly. So please make sure you're showing all 3 components. In other words, everything that I do on my notebook paper, you should have on your notebook paper. And then join for Zoom help according to your teacher's schedule. For Ms. Robinson, that's 1:40. For Ms. Allen, that's 10:25 a.m. And Ms. Klein-Pierce has her hours as well. So touch base with her if you have questions about that. So I'm going to go ahead and transition over here to your Delta Math assignment. If you look up here on your assignment for today, on 1118 Angles of Elevation and Depression, you are required to take these notes. You're welcome to take a screenshot, but you must include them in your notes. I highly recommend that you write them down. I am finding that students who don't write things down, when I ask them questions, they don't know, because part of the learning process is to write things down and commit it to memory. Some people are very visual and can do it that way. Other people need to write it down. So I encourage you to write it down. So I'm gonna click on this in just a minute, and we're gonna go through it. But you can see there's only 8 problems, and like I said, I'll be working through the first 4 with you, and then I'll help you with setting up the others, and you'll do these independently. So your notes, and feel free to enlarge your screen so you can see it well. So right here it says right triangle trig, angle of elevation and depression. So I want you to think about if you're in an elevated mood, or think about an elevator going up and down, or an escalator that might remind you of going up, okay? So elevate to lift. So these angles of elevation are going to be, if you look at this picture down here, the angle of elevation is going to be this angle formed that exists between this horizontal line and your line of sight. A line of sight is the sight line where you're looking from your eyeballs up to an object upward, okay? So you've got this horizontal line, and then you're looking up, and this angle here is called the angle of elevation, the one here at the base. So again, that's what's illustrated here, an angle between the horizontal line and the line of sight. So if I were you, I would, you don't have to draw the hot air balloon and all that. You might want to put a stick person down here, but at least draw this image here and label all the words here in your notes. The angle of depression, if you think about depressed, usually if somebody's depressed, they're kind of feeling low. So depressed, think down. So an angle of depression is an angle formed from the horizontal line way up here and of line of sight. So let's say you're up in the hot air balloon and you're looking down at this person. Then this angle right here would be the angle of depression because you're looking downward. Okay? So angle of elevation is from the horizontal up, angle of depression from the horizontal down. But notice I've got a measure here of 38 degrees and this one here of 38 degrees. So why are they the same measure? You might recall that if you notice these two horizontal lines are parallel, and we did a whole unit on parallel lines and transversals and angle relationships. And what I need you to remember from that is that when you have a set of parallel lines cut by this sight line, which can be looked at as a transversal, then alternate interior angles are congruent. So you've got these two parallel lines cut by this transversal, alternate interior angles are congruent. So the angle up here would be the same as the measure of the angle down here for the angle of elevation. So, and that's what I just described here, that the two horizontal lines are parallel to each other. The angle of elevation and depression are congruent, and angles that do this are alternate interior. And then it says if you draw in a vertical line, then a right triangle is formed. So think about it. If I were to draw a vertical line, remember vertical goes up and down, from this hot air balloon down to the ground, it would be perpendicular to the ground, therefore form a right angle down here. So that's really what we're going to be doing. Same up here. I could draw a vertical line from right here down to this person, and it would form a right triangle as well. So therefore, we're going to be allowed to use our right triangle trig, SOHCAHTOA, to help us solve these problems. All right. So I'm going to go ahead and back out of that. If you're not through copying, just hit the space bar to pause your video. So the next thing I'm going to do is, notice I've got all these different problems here, but I've got them labeled like to describe it. So number 1 is regarding the height. You're going to be finding the height of a tree. 2, you're going to find the depth of a submarine. 3 involves an escalator. And the first couple have pictures, and then we're going to have to learn, well, what if they don't give us a picture? And then we have to draw it. So we're going to go ahead and take a look at number 1. I'm just going to read over the instructions one time because the instructions repeat for every problem. But these are teacher-created problems, so you do not have the option of hitting show examples and watch a video. This is the video. So it says, sketch a picture to represent the scenario, including the right angle. Fill in the given information. Label the sides where you wrote values. So if you put a number or if you put an X, label those on the sides, rather, with O for opposite, A for adjacent, and H for hypotenuse, as it relates to the angle you are finding or the angle that you are given. Then you will solve for the requested value using the appropriate trig ratio, rounding to the 10th place. So we're given this picture here, and notice I have embedded a right triangle on top of it. It says a palm tree casts a shadow of 18 feet long. The angle of elevation of the sun is 25.7. Find the height of the palm tree. So I want you right now in your notebooks, let me go ahead and open mine up and show you what I did, to always label your notes. One thing I'm finding is that some of you are turning things in and then you have a notebook full of work, but it's not labeled, and that's not going to be helpful when you are trying to study and you don't even know what you're looking at. So make sure you're labeling. So today's assignment, 1118, DM for Delta Math, angles of elevation depression. Here's where you would put your notes. I'm just going to go ahead and start with problem 1. And problem 1 had a picture that looked, again, like this. So I'm going to draw this right triangle in my notebook. And we got to think about what things represent. So notice that this side of the triangle is going to represent the palm tree's height. So I'm going to write in my notebook, I'm going to write height on that side of the triangle. Down here, the shadow, it says the shadow is 18 feet long. Where's the shadow? The shadow's on the ground, right here, right? So we're going to have a shadow here on the bottom. And they tell us the angle of elevation. So remember, elevators go up, so it's this angle from the horizontal up to here, going upward, to this side going upward. So this angle right here is 25.7. All right, and again, the shadow is 18 feet long, and they want us to find the height of the palm tree. So here's my picture so far. So I have a right triangle as drawn. The height of my palm tree would be this side, the shadow on the ground. The length of my shadow is 18. The angle of elevation I have filled in as 25.7. And our job is to find the height of the tree. So I'm going to put an X over here to represent height. So remember that if you highlight the sides of the angle given, then the side not highlighted is the opposite side. So it's way across over here from this angle, 25.7. This side here, you got to decide if it's the hypotenuse or the adjacent. Remember, the diagonal side opposite the right angle is always the hypotenuse, so this makes this the adjacent. Remember, the word adjacent means next to or beside. So this side is right beside this angle, so that's going to be labeled adjacent. And again, if we highlight the sides of the given angle, the side that's not highlighted will be the opposite. So our job is to decide what trig ratio to use. So at the top of your page, I want you to write, and I'm going to write this because I've noticed that some people are forgetting to put in their angle. That sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle, let me rewrite that. Tangent of an angle is equal to opposite over adjacent. So ka toa. So ka toa. And it has to be in that order. O over H, A over H, O over A for tangent. Okay? So when I look at this and I see that I've labeled an O and an A, that directs me to use the tangent ratios. So that means I'm going to say tangent of my angle measure, which is 25.7, is equal to my opposite side, X, over my adjacent side, 18. So when we did solving for sides using trig ratios, I showed you that you could make it look like a proportion. Miss Allen shows that you can take this 18 and just stick it up here in front like this. But also, you either understand that or you're still confused. So if you're confused, remember that when solving for x, the inverse of dividing by 18 is to multiply those sides by 18. And when you do that, the 18 cancels. So that's why the 18 ends up over here. So that means our exact value would be x equals 18 tangent 25.7. But we need to find the approximate value rounded to the 10th place. Because in here, in the instructions, it says round to the 10th place. So if I type this in, rounded to the 10th place, make sure your mode is in degree mode. So let me flip this back. Hold on just a second. All right, sorry about that. So if we use our TI-84 graphing calculator, if you have one of those, you're going to change it from, remember you hit the mode button, which is right here to the right of the second button. Change it from radian to degree by hitting enter. If you are using your Calculate 84 app, then we can, from mode, choose degree. So again, it's normally on radian. Just tap degree and hit enter. Then when I hit second mode, I can type in 18 tangent 25.7, exactly like you see it on paper. So let me focus it so you can see it well, hopefully. So 18 tangent 25.7, and we have a value of approximately 8.7. So remember, we're rounding to one number after the decimal. If the second digit is 5 or higher, it makes this first digit in the 10th place go up 1, so 8.7. So it's approximately 8.7, and this is what I want to see, guys. So remember I mentioned that some people were not showing everything. You have to show everything in order to get credit. So make sure you're drawing the triangle, you're labeling, you're putting your O, A, or H, you're showing the original trig equation, showing the work, meaning what you type in your calculator, and stating the answer. And please put a box or something around it, okay? So I'm going to go back here to Delta Math, and you all should as well. Type in your answer of 8.7, and that will be correct. Notice you can't just, it'll just tell you if it's correct. If you get it wrong, you're not going to have multiple, do I have it set to multiple attempts? Let me see. Yeah, I actually have it set so that you can try multiple times. So if you're getting to your third and fourth try and you're still confused, please, please, please reach out to us when you're doing these over here on your own. All right, so moving on to number 2. I can enlarge it here so you can see the picture really well. Notice this time I don't have a triangle. And it says the sonar, so if you don't know what that is, that's when they send radio frequencies to bounce off an object and then they can measure how far it is. So the sonar of a Navy cruiser, so this is your Navy cruiser, detects a submarine that's 4,000 feet away. It's 4,000 feet. So just think if you jumped off the boat and swam to the submarine and they were standing still, it would take 4,000, you would swim a distance of 4,000 feet, okay? The angle between the sea level, so that's up here, the top of the sea level, and the submarine, so this angle up here down to the submarine is 34 degrees. How deep is the submarine? So I'm going to keep that picture in mind. In fact, I can just do this, keep it to the side. I think, there we go. And then draw my picture over here in my notebook. So again, for number 2, I'm just going to draw, that you've got this, I'll put NC for Navy cruiser. You've got this submarine down here. The distance from here to here is 4,000 feet. And it's asking you how deep is the submarine. So how deep is it? So from here to here, sea level to here, how deep is that submarine? So therefore my right angle would be up here. So if that 4,000 seems confusing, we can always move it to out here on this side of the triangle. So we've got a Navy cruiser 4,000 feet from the submarine. It tells us the angle of depression. So remember the angle of depression is from the horizontal downward. So from here to here, this angle is 34 degrees. So I'm going to put in 34 degrees. And they want to know how deep is the submarine. Well, that would be from the top of the water down below. So we want to know this side. All right. So I'm going to close that now. And we're going to talk about again how we would label it. If you would like to pause the video at this time and try it yourself, that would be wonderful. So feel free to hit pause, work it out, and then resume the video so you can check your answer. So this video, sorry, not this video, but for this triangle, this side way over here, again, if I highlight the sides of the angle that I'm given right here. So remember I used to use, when in the original video I used a peace sign, right? So these two sides here are next to this angle 34. They're beside it, but this side is your opposite. The side not highlighted here would be your opposite. This side is the diagonal side across from your right angle, so it is the hypotenuse. So since we have O and H, if we refer back here to SOHCAHTOA, O and H means we're going to use sine. So we're going to write sine of the angle measure. So sine of your angle measure 34 equals the opposite over the hypotenuse. And this is set up the same way this is. The only difference is it's a sine ratio instead of tangent. So we solve it the same way. So again, if you want to just put it up here, or remember that you multiply both sides by 400, as finding the inverse of dividing by 400. So our x is going to be exactly 400 sine 34, but we are going to approximate that to the 10th place. So in our calculator, remember once you've changed it to degree mode, it should stay degree mode. You should not be getting small decimal answers. So that's 223.7. 223.7. So I'll go back in here, enter 223.7. Uh-oh, what did I put the first time? Let me just make sure what I already worked them out. Did I just not type in the answer right? Oh, I think I've typed something in wrong. 400. Oh, it was 4,000. Oh, that's why. Sorry about that. So I'm just going to add on another 0 here. It was actually 4,000. That was my fault. When I wrote it up here, I just forgot a 0. So we would need to multiply by 4,000. And that's why we check our work, right? And you get multiple attempts. So again, if I now do 4,000 times the sine of 34, I get 2,023.8. I even said it wrong. 2,236.8. All right, so 2,236.8. Oops, sorry, because this 7 makes this 7 round up to an 8. Okay, so again, I should have had a 4,000. Thank goodness we get multiple attempts, right? So just to make sure I've got the correct answer typed in for you guys. There we go. Sorry about that. All right, next. So now we're going to do a problem with an escalator. So this is the last one, really, where I give you the full picture. So in our notebooks, for number 3, I'm going to just draw a right triangle. I don't have to make this side look like stairs, but you can if you like. And what does it say? It says an escalator from the ground floor to the second floor, oops, I need to fix that, of a department store is 110 feet long and rises 32 feet vertically. What is the escalator's angle of elevation? This right here, the angle of elevation. Bet if I just refresh it, it'll be fixed. I think Miss Allen hooked me up and checked my spelling for me. So the angle of elevation is going to be this angle that I'm trying to find down here. Yep, she did. Look at that. All right, so my angle of elevation, again, is from the horizontal upward. Elevators go up, so think this angle right here is x, and that's what we want to find. So this is different. We're finding an angle now. The other two were sides. So let me get this out of the way. So if I'm solving this, again, if I put highlighter on the sides of my given angle and think, how would I label these two sides? Then the side not highlighted or way over here is the opposite. And the diagonal side is my hypotenuse. So O and H, we're going to use sine again, right? So remember, it's always sine of your angle. If we do not know the angle, again, that means we're going to be using sine of x. So sine of x equals our opposite value, which is 32, over our hypotenuse 110. So remember that angle goes with inverse, so you need to remember that. If you're finding an angle, we use the inverse. Angle inverse, angle inverse. Think A-N-I-N. When I want to find the angle, I use the inverse operation. So that means x will be equal to the inverse of sine. And recall on your calculator that means we're going to be pressing this to get this sine inverse, which is, it looks like sine to the -1. We're going to hit the blue second button, then sine. So what else? Inverse sine of 32 over 110. And what is that approximately? So if we hit second sine, 32 over 110, whether we're using these calculators or the one on our phone, we'll get the same answer. And that's about 16.9 degrees this time. 16.9 degrees. And speaking of that, by the way, the fact that we'll use inverse, one of the things I forgot to mention is that back here in problem 1, oops, where'd it go? Back here in problem 1, in addition to copying these notes, you actually have some stuff to answer. So make sure you're filling this in. 1, 2, 3, 4, 5. You got 5 fill in the blanks. They're pretty easy, so I hope you don't miss them. But make sure you go back in there. These are some really, really good reminders of what you need to do. So make sure number 1 is finished, okay? Even though it says required notes, it is weighted. You do have to answer it to get full points, okay? So next, moving on to 4, I'm going to kind of do 4 with you because it's another angle. And then 5, 6, 7, and 8, I'll help you with drawing the triangles, but you're to solve those independently, okay? So next with number 4. Ooh, oh my goodness, we do not have a picture. What in the world? So I'm going to talk to you about how we can look at a word problem and think about what the picture would look like. So we're looking at this paragraph right here. So for number 4, it says, you are 200 yards from a river. Well, if I asked you, in 3rd grade to draw a river, you might do something like that to represent water, right? So this will be our river side. And then it says you are 200 yards from a river. So let's imagine you're right here. And you are 200 yards away from the river. But it says rather than walking directly to the river, which would be perpendicular here, like the shortest distance, it says you're going to walk along a diagonal path. So you're going to walk down this diagonal path instead, and it says that this path, so imagine this being like a sidewalk, this sidewalk is 400 yards to get to the river. What is the angle? So think about this here being perpendicular, so that's where a right angle is going to go. What is the angle between the path, which is here, this is your path, and the river's edge? So we're talking about this angle right here. What is this angle? So let's put an x here. And that's our job, is to solve for that x. All right? So like I said, I'm going to solve this one extra one, but I would love, since I just did an angle problem on number 3, if you would please pause the video, work it out, come back and check your answer. So for this particular problem, if we've got x, and again, if we highlight the two sides of our angle, whether it's the x that we're finding or the angle that we're given, then remember I said you could use your p sign, right? That this side way over here is your opposite side, and the diagonal side across from the right angle, opposite the right angle, is your horizontal side. Or excuse me, hypotenuse, not horizontal. So O and H tell us to use sine. So we're going to say sine of our angle equals opposite over the hypotenuse. But remember, our job is to use inverse operations when we solve something. So x will be equal to inverse sine of 200 over 400. So again, we access that inverse anything, whether it's the cosine, sine, or tangent. It does not matter what the ratio is. It is not always sine. We're just going to hit second sine because we're trying to find the angle when we know the length of the opposite and hypotenuse. So this tells us it's actually exactly 30 degrees. So just type in 30 and you're good to go. So that was the first one we did where they didn't really give you a picture. So I'm just going to, like I said, help you, but I'm not going to finish working them out. Because I know it takes some time, but if you want to try it on your own and then resume the video to see if you drew them correctly or if your picture looks similar to mine. Not everybody always draws them the same, but we always should get the same answer. So feel free to pause it, and we're going to do a skateboard ramp problem. Pause it and try to work that one out. Draw a picture, and then if you want to just resume it and see what my picture looks like compared to yours, and if it's labeled correctly, that's cool. If you want to work the whole thing out and just see if it matches my answer, that's cool as well. So it says, for number 5, a skateboard ramp at a park has an inclination of 54 degrees, and its base, remember base is the bottom, is 12 feet long. What is the length of the ramp? So, I think I will think about if I were driving or riding on a bicycle or something, and I clearly can't draw. But say I'm holding on to these handlebars. I got some kind of bicycle right here. And I am trying to ride that bike up a ramp, or maybe you want to do a skateboard, or maybe no picture at all. That's fine. So if I want to go up the ramp and it says what is the length of the ramp, I'm going to label that X because I don't know what the length is. But it does say that the base of this ramp is 12 feet long. I'm going to finish that vertical segment off to create that right angle. What is the length if, what else does it say? The ramp has an inclination. So that means, think about inclined. Incline is increase. So that's our angle of elevation. So down here it's 54 degrees. All right. So your job is to finish solving that problem. I'm not going to work it out for you. That's your job. Okay. And then make sure you type your answer in down here to verify it. And you will have, like I said, 5 attempts in case you do something wrong. But again, if you're getting to the 3rd and 4th and 5th try consistently, you should ask us for help. So for number 6, same thing. If you'd like to pause the video, you can. But I'm just going to try to walk you through how to think about drawing it. You know each time it's going to be a right triangle, right? So if you want to just draw the right triangle first and then think about how to label it, you can do that too. So I can draw a right triangle. You might prefer that better. So it says a ladder leans against a house. Well, which side would represent the ladder if it's leaning? Well, I think it would be this side. So I'm going to kind of make it look like a ladder. So let's say I got a ladder and it's leaning against a house, and I know houses go straight up and down. They have a perpendicular side here. So we're going to pretend, we're in 2nd grade, and that's how we draw houses, because I can't draw. So we got a ladder leaning up against a house. What does it say? It says the ladder is 20 foot. So that tells me to put the 20 there at the hypotenuse. And the base of the ladder, base is bottom, is 5 feet from the base of the house. What is the angle formed by the ladder and the ground? So that means, what is this angle? All right. So your job is to continue to solve that and input your answer. For number 7, got a car to a tower. Let's see what this one says. It says, the angle of elevation from a car to a tower. Well, again, if you want to just draw in your right triangle and then kind of put in the picture. Some of you may want to do the picture then the triangle. Doesn't matter. So let's see. Clearly this side would be the tower, right? A tower would go up and down. Maybe it's like a cell phone tower or something crazy looking. So it says the tower is 150 feet tall. And the angle of elevation from a car, remember, angle of elevation is this one down here. So this angle of elevation is 32 degrees, and we got a car down here. So if you want to just put a C for car, or I don't know. I feel like I'm a preschooler when I draw. I'll put a window in there. So there's my car. The angle of elevation is 32 degrees, and they want to know how far is the car from the tower. So again, this is my tower, this is my car. How far? So that's where my X goes. So you'll finish solving that one. Let's see about number 8. So I hope these pictures are helping you, but like I said, if I were you, I would try them on my own and then kind of see how I'm doing them. Hit pause and draw it and then compare. And the reason why I say that is because on your test, you have 2 problems. One will be solving for an angle. One will be solving for a side with angle of elevation depression. So 2 questions from this lesson will be on your test. But we're not going to give you the picture. So you need to be able to draw it. At least here I give you a little bit of an image, right? So we've got here that Richard is flying a kite. So Richard, so think about your triangle. We got Richard chilling down here, and he's flying a kite. So it says the kite string has an angle. So this is our kite string, right? Because if the kite is up here, then the string is from here to here. And it says, if the kite string has an angle of elevation of 57 degrees, so that's going to be down here at the bottom, Sean is standing 100 feet from the point on the ground directly below the kite. So think about directly below the kite. He is standing 100 feet from this point. So remember, Richard's here and the kite's up in the air. He's holding it with his hand, so technically the ground is down here. So at this point here, he's standing 100 feet from this point. Find the length of the kite string. Okay, so that is what you will solve there. All right, so good luck on this assignment. Like I said, if you're getting to the 4th and 5th and still struggling, please, please, please send us a message and get together with us. Do me a favor, and if you're still listening, at the end of this video, at the very top, at the title of your notes, up here, put SC with a circle, okay? So if you're still listening, come up here and put SC and circle it, and that'll tell us when we check your notes if you made it to the end of the video. All right, thanks and good luck.